Leetcode problem 844, backspace string compare. So for this problem, the hash is just a backspace. So for example, we're gonna press, first of all, we have C and C, they are equal, it is okay. And then we're gonna press backspace, it means we're gonna delete this B. And here we're gonna delete this D, and we're gonna compare this A and this A, they are equal. So we're gonna return true. But we will not use the stack to solve the problem because the stack is too naive. Yeah, because we will solve it by using the follow-up question. Can you solve it in O(n) time and O(1) space? So if we want to solve some problem like that, definitely it's gonna be much harder than before. It's gonna be a hard medium problem. So we have like A, B, hash, and C. This is our string S, and we have another string T. So this T gonna be equal to AD and hash and C. Yeah, let me make it better. So it's gonna be AB AD hash and C. Yeah, so how should we solve this kind of two strings? Normally we're gonna use two pointers. Because the hash is just to do the stack operation. Basically, it means we can start the pointer from the right to the left, because in this way there will be no influence to the hash operation, to the backspace operation. So if we go from the right to the left, normally it should be okay. So this is just for simulating the problem. But actually for solving the problem, it is much harder. It's not because you cannot think about how to do it. It's just because it's a lot of edge cases, and you have to deal with the edge cases. Now, the problem focuses on how to solve this hash. So the hash is just a backspace operation. So I'm going to use two pointers to two variables to represent the hash. So for the string S, inside there are going to be a lot of hashes, and I'm going to use a escape S. So this means if I meet a hash, so for this string S, I have a counter of 1. So it's gonna plus equal to 1. Yeah, so it's gonna plus equal to 1. Yeah, so the escape S would plus equal to 1. So if I meet a hash. Now the problem is that while there's no hash, so for the next character, for example, this is B, it is not a hash, but I have the skip S, it is 1, so this means I can skip this B, I can go to A. So this is just for the operation to how to solve that. Yeah, because definitely there are going to be a lot of hashes in this string, and we have to find a way to record a variable skip S to check how many hashes do I have up to now. So for example, up to here I have 1 hash, and so it goes to B, it is not a hash, so my hash counter is 1. Yeah, so this means I can skip this B and I will go to A. And similarly for the string T, it means I'm gonna skip this D and go to A. Yeah, so finally I just need to check if this A equal to this A or not. So if they are equal, so I'm going to the next. And here, another variable J will also go to the next, another pointer. So this is going to be -1, and here going to be -1. So finally, I just need to compare if they are equal or not. So if they are equal, so I'm going to return a true. Otherwise, I'm going to return a false. Yeah, now let's just try to solve it. We're going to use two pointers. It's going to be the string S -1 and the length of the string T -1. Now we are going to check this I more than equal to 0 or J should be more than equal to 0. And this is just for the outer loop, but for the inner loop we should check one by one. So let's first check S. So if I more than equal to 0, and we need to check the string I. So if it is equal to hash, so this means we need to have a counter. So we're gonna use let me use escape S, so plus equal to 1. So let's just define two counters. So escape S and escape T. So it's going to be 0 and 0. Yeah. So if this is skip s plus equal to 1, so I need to move to the next pointer. I mean, it needs to go to the left. Yeah. So I would plus it minus equal to 1. So elif si currently it is a character. It's not hash. Yeah. But the skip elif the skip is more than 0. So this means I can skip it. Yeah. So if I can skip it, so my skip s should be minus equal to 1. And I should minus equal to 1. And because I want to skip this one, definitely I should also minus equal to 1. So else, so this means it is a character, but my skip equal to 0. So I cannot skip anymore. So what I'm gonna do? I'm gonna break it, and I will check the outer loop from here. Yeah. Now let me just copy the same code, because the principle is similar to the string t. I just need to change this I to j. So here, let me just update this I to j, and it's gonna be skip t, and this gonna be tj equal to hash, and this gonna be skip t. Yeah, it's gonna be the similar, as you can see, for this j. Yeah. So if we go out of the while loop, basically we can check this I and j. So if this I more than and equal to 0, and j more than and equal to 0, and si are not equal to tj, so I can return a false immediately. Yeah, so this means we have a string s. This is s, and this is t, and inside definitely there will be some hash, or there will be some characters. We don't care. Yeah, we don't care about that. But at some point at this position, there's a character c maybe. Yeah, there maybe before that, after that it maybe has or maybe a character, but it has already been handled. Yeah, so it, and in this area it also has already been handled for this string t. But here we have a character, for example this is d. But if this I more than and equal to 0, j more than equal to 0, but si not equal to tj. So if they're not equal, so what are we gonna do? We're gonna return false immediately, because this area has already been handled and this area has already been solved. So we're gonna just compare if this is equal or not. But what if this character is still same? So what are we gonna do? Yeah, if it is still the same character, we're gonna go to the next. Yeah, here we will also go to the next. Yeah. So if it is not, so I should minus equal to 1 and j should minus equal to 1. Finally, we just need to check if this I equal to j or not. I think this way is much simpler to write the code. Yeah, because definitely in some cases it will go out of the boundary. So maybe let's just use an example. In the right area it has already been solved, and here I have a cd. Maybe I have yeah, this is 2 hash. I have 2 hash and with cd. So definitely I can delete this one and delete this one, and here I have a -1. Yeah, but for another string t, so I only have a character c maybe. Yeah, so this is c, j pointed to c, and this pointer is 0. This index is 0. Yeah, so it means for this string s, it go out of the boundary. It becomes -1 and it can go out of the loop. Yeah, because here is the final check. If it is I less than 0, I will go out of the loop. Yeah, but for the j, the index is 0. This is -1. This means yeah, they are not equal, because here I have a character, here I have nothing. So finally I have to check if this I equal to j or not. Yeah, and sometimes I equal to j to -1. Sometimes I equal to j equal to -2. Yeah, because in some cases maybe yeah, maybe we have a hash, we have a character. This is for s, we have a has, we have another character d. This is for t. And for this one, I've deleted and I becomes -1. And z also becomes -1. But here I have a I -1 and z -1. This means it becomes -2 and -2. So this means I have to compare I equal to z or not. I cannot compare I equal to z to -1. Yeah, because it have two different values. Now let me just run it to check if it works. So as you can see, it works. Now let me just submit it to check if it can pause. As you can see, it paused and it's pretty fast. So the time complexity becomes linear, so it is O(n), and the space complexity has already become O1 because we didn't use any extra space. So normally if we are going to solve some problem using O1 space, definitely we're going to use the two pointers, and definitely there will be a lot of edge cases we have to handle. This is not an easy problem anymore while we are using the O1 space solution. Yeah, definitely this is difficult to think. Yeah, even though you can think about it, there are also some other edge cases, and you have to handle all the edge cases. So thank you for watching. See you next time.